Servus and welcome to the next lesson of the free WU BBE Entrance Exam preparation course. This video is on Elementary Algebra, which is the fundament of everything else you will learn in this course. You will encounter it in nearly every topic. So if you go and learn elementary algebra well, you will save so much time later on. Today, we won't cover all topics of elementary algebra because it's just too huge. It's a very big topic, but we will cover some important concepts which frequently showed up in the entrance exam in the past and are expected to show up in the future. As you know, you can find the solutions and more examples of these tasks on our website. Just go to bbeinsider.com/YouTube or scan the QR code with your phone. Let's dive right into it. Elementary algebra is the heart of mathematics. It contains a number of rules you will encounter over and over again. On the screen, there are represented the most important rules on basic operations, exponents, fractions, and of course, this list is not exhaustive, meaning that there are many more rules you should be aware of. But there are so many, they don't even fit on the screen. So let's stick with those. Maybe take a screenshot for your further preparation if you want to go back and revisit them. And now let's just go to the very first task. You will encounter something like that in many situations. So let's try to simplify the form of this expression together. To simplify this expression, you need to multiply each term from the left parentheses with each term from the right parentheses. I want to highlight this with a color so it's easily visible for you. So let's start with the first set of calculations. 3x to the square times x plus 7x times x minus 2 times x. So then we go on with the second set of multiplications, which we will denote like this and write it in blue. So plus 3x to the square times 6 plus 7x times 6 minus again 2 times 6. In the next step, we multiply each term. 3x to the power of 2 times x is 3x to the power of 3 plus 7x to the power of 2 minus 2x plus 3x to the power of 2 times 6 is 18x to the power of 2 plus 7x times 6. 6 times 7 is 42x minus 2 times 6 is 12. I highly recommend you try a lot of basic calculations in your head because this way you can save so much time on the actual entrance exam. Now we go on and combine like terms. Like terms are these with the same power. So x to the power of 3 is just once. Then we have x to the power of 2 here and here. And then just x to the power of 1 or just x is here. And then we have a term even without any x. When combining like terms, you just add them up. After combining these like terms, we have our result, which is 3x to the power of 3 plus 25x to the square plus 40x minus 12. Let's go on with the next example. This one is a bit more sophisticated. We will determine each single statement on its own. But first of all, we will define what the actual absolute value is. The absolute value of x depends on the value of x. If x itself is larger or equal to 0, the absolute value of x is just x itself. But if x is smaller than 0, then you have to plug in a minus before the negative value of x, which in turn cancels out and provides an absolute value, because the absolute value is per definition the distance from the value to 0 on the number line. Let's go with an example. Let's define x as minus 2. Of course, in this example, it's very easy to check if x is greater or equal to 0 or smaller than 0. But if we add something like a variable and define x as minus 2 plus a, where we don't know the exact value, we have to check both cases. But let's be concerned with these approaches in the next sections on equations and inequalities, and let's stick with the easy and basic things for now. Because x is minus 2, it's smaller than 0. So if it's smaller than 0, we replace minus x with minus, because we defined x as minus 2, which gives 2. Very easy, right? So let's keep this in mind when going through the examples. Let's start with the first statement. Considering the definition of absolute value, which is the distance to 0, we know that the distance from minus x or the distance from x will always be the same. Therefore, for any real number x, the absolute value of minus x and the absolute value of x is the same. Therefore, the first statement is true. For the second statement, we have to note that the absolute value of x plus y is not equal to the absolute value of x plus the absolute value of y in general. Sometimes it's the case, but we have to view this statement as a general statement, and therefore we have to consider all cases. And generally speaking, it's not the case always. However, it always holds true that the absolute value of x plus y is smaller than or equal than the absolute value of single components. Let's check with a numerical example. Let's define x as 3 and y as minus 4. Now we plug these numbers into the formula and check if the statement is true or false. When we plug the numbers of our variables into the initial formula, we clearly see that this statement is not equal, because the left-hand side is 1, which is definitely not equal to 7. Therefore, this statement is false. For the third statement, we have the absolute value of minus 2, which is then raised to the power of 2.5. And we want to check if this is equal to the square root of 32. How could we approach that? First of all, we determine the absolute value of minus 2, which clearly is 2. Then we raise 2 to the power of 2.5. As you know from the rules on exponents, we could express this also in the form fractional exponent. This way, we could also visualize it like a square root and raise it to the power of 5, because the rule says that x to the power of n divided by m is equal to the mth root of x to the power of m. This is what we have applied in this case. Now we just calculate the fifth power of 2, which is this, and equals 32. Therefore, the statement is correct. For the next set of statements, you need to be cautious which kind of root you deal with, because there's a difference if the root is even or odd, as you see in the summary on the right hand side. For even roots, we say that in real numbers, the root needs to be taken from a non-negative number. However, if the root is odd, like in this case, we can take it also from negative numbers. Let's think of the number 16. The square root of 16 is 4, because 4 to the power of 2 is 16. However, minus 4 to the power of 2 would always also be 16. There is no way to get minus 16. And therefore, we say that for even roots, we require non-negative numbers in the set of real numbers. For odd roots, however, it's possible to take a root of a negative number. This is the case because we can calculate minus 2 times minus 2 times minus 2, which gives, in this case, plus 4 times minus 2, and the whole results may yield a negative number. Now you see the reason behind the prerequisite that for even roots, the number that you take the root of needs to be non-negative, because we would never attain a negative number with an even number of multiplying a negative number with each other. Now let's consider the first statement. The first statement is the cubic root of minus 27. Because the root is odd, we can take it from a negative number. We just calculate the cubic root from 27, which is 3, and then we can add the minus in front of 3. That's it. Therefore, this statement is true. Now let's talk about the second statement. The nth root of x to the power of n equals x for all real numbers. X is an element of all real numbers. Remember that the real numbers could be either negative or positive, and any integer n means this could be positive or negative again. Let's consider the situation when n is even and x is smaller than 0. Let's say x is equal to minus 5. Then we have the situation that we take an even root, let's say it's 2, of a negative number, which we said before is not defined, because there's no way to multiply two equal numbers with each other, which yield minus 5. Therefore, this statement is too general and doesn't hold true in all cases. Therefore, it's false. Let's talk about the last statement. The fourth root of a negative number is not a real number, meaning that n is equal to 4 and the number is smaller than 0. Combining these would yield something like that. As we discussed in the beginning, the fourth root or any even root of a negative number is not real. Therefore, the very last statement is correct. Let's move on to the next set of statements. As we discussed in the beginning, elementary algebra is the application of a set of rules. In this example, you should be able to recognize that we can apply the rule difference of squares for the first set of parentheses. I showed you a set of rules in the beginning of this video containing the definition of difference of squares. Now, here it is. If you consider the first set of parentheses, you see the similarity. Based on that, you can proceed with the calculations so much more easily than if you just go and multiply each parenthesis with the others. Once you know these rules and you are able to recognize how to apply them, like in this case, you will save yourself so much time, because multiplying each single parenthesis with the other ones takes so much time, and you actually are in a time stress during the entrance exam. So we will proceed from here. We just applied the difference of squares with a equals to x to the power of 1 over 3 and b equals 3. So now we have to take the square of x to the power of 1/3. Now let's proceed by raising x to the power of 1/3 to 2. Based on the set of rules of exponents, which were also covered in the beginning of this video, we encountered this situation. X to the power of 1/3 to m. You can simply multiply the exponents with each other to get to the result. Let's do that. 1/3 times 2 equals 2/3. Minus 3 to the power of 2 equals 9. Now, let's note the new form of the expression. Now, we used these results and plugged it in to the highlighted set of parentheses, which equals this first parenthesis. So, now let's use the difference of squares once again. We apply differences of squares once again, and that yields x to the power of 4 over 3 minus 81. We plug this into our initial expression, and then we simplify it to get the final result. We put the result of the differences of squares back to the original expression, and now we simplify it once again. First of all, the thing you need to know is when having a statement like this, you could distribute x to each single term. This is what we did right here. In the next step, we used the rule provided in green to simplify this expression. If you divide x to the power of n by x to the power of m, you can simply subtract the exponents n minus m. This way, we obtain x to the power of 1/3. And this is the way how we solved the initial expression and simplified it to x to the power of 1/3 minus 81x. To solve this task, first of all, we start with simplifying x, y, z. Put it into one parenthesis and raise it to the power of -2. Next, we try to figure out what we need to do with x, y, z to the power of -2 to obtain x, y, z to the power of 4. For that, we use this rule. If we raise x to the power of n to the power of m, we have the possibility to multiply the exponents. Therefore, we have -2. What do we need to multiply -2 with in order to obtain 4? We need to multiply -2 with -2 to obtain 4. Therefore, we raise this whole expression to the power of -2. Now we figured out how we need to deal with this side of the expression. Of course, we need to deal with the other side of the expression the same way in order to ensure both sides stay the same. Therefore, we take 1 over 4 and raise it to the power of -2. The second rule tells us that when we have a negative exponent, we can take the reciprocal in order to turn it into a positive exponent. This is what we will do next. In order to deal with such a situation, I like to use the double fraction. 1 is nothing else but 1 over 1. And then we distribute the power of 2 to the numerator and denominator of the fraction. 1 to the power of 2 is just 1, and 4 to the power of 2 is 16. Now we multiply the outer parts and the inner parts of the fraction. 1 times 16 is 16, divided by 1 times 1 is 1, And now we have our result, which is 16. So first of all, we calculated the left-hand side, x, y, z to the power of 4 equals 16, the right-hand side. This is how to solve these kind of tasks. This task is finished, and now you have the opportunity to check your skills of elementary algebra with an exam-like task. Your task is to determine if these statements are true or false. You will find the step-by-step solutions for this task on our website next to other tasks which you can try to train for the BBE Entrance Exam. I hope you enjoyed this very entry-level video on elementary algebra. You're invited to sign up on the website to train more for the BBE Entrance Exam. Moreover, on the right-hand side, you will find other videos of this free preparation course. See you in the next one.